Can you hear me? Yes, it works. Hello everyone. Welcome to this session today on blade recycling and more. My name is Gioffrè. I'm Sustainability Advisor at WindEurope. I'm very glad to chair this session today. Literally this morning I was in the room next door, also on a session on the Circular Economy Act. So there we were talking about similar conversation that we will be having today with the presenters, but more from a policy perspective. Now we're trying to delve into more the technical side of things, more, let's say, the more technical discussions that maybe are, they're important to have as well, because of course we do talk about policy, but it's extremely relevant to also dig into the more complex, in a way, side of the story. The reason why we do this is quite obvious, I would say. We see more and more volumes of blade waste that will come to, of blades that will come to end of life in the coming years. At the moment, we can count around 20,000 tons per year, but this figure will be growing more and more in the coming years, up to even 80,000 tons to 2050. So that's the scenario, and to kind of scope a little bit where we stand with the issue, let's say. I'm actually holding in my hand, I don't know if you've had the chance to pass by the WindEurope stand. This is a bookmark, but it's actually a blade recycled bookmark. Like, it comes from blade waste, supposedly, but as you can see, we have also this, we can tell these stories as well, that we can do something with this, with what is considered waste, but we can also call it just a secondary raw material where we can do something with it. So this and more interesting things will be covered today, and I'm very happy to be joined in the panel by Justine to chair the session. And
yes. My name is Justine Beauson, and I'm a senior scientist from DTU Wind Energy in Denmark. And my expertise is in the recycling of wind turbine blades. So I'm very happy to co-chair this session on circularity. And also very happy to welcome our three speakers. So today you will hear Marta Barreras. You are CTO from the company RenerCycle. We'll hear Nacho Montesinos Beltram from AIMPLAS, and we'll hear David Garcia from Iberia. For the moving around the cycle, we'll talk about recycling. So, and it will be Nacho from AIMPLAS.
Okay, thank you.
The floor is yours.
Okay, well, hello. My name is Nacho. I work in AIMPLAS, a technological center located in Valencia, and I will explain about the advanced pyrolysis and solvolysis process for circular recycling of wind turbine blades, recovering glass fibers and high-value chemicals. So only to put into context who we are and what we do, we are focused on the R&D and technological service, and also training and workshops, and we cover our expertise across the entire plastic value chain, with the polymer synthesis to obtain these raw materials, later the compounding, different manufacturing processes, to obtain the final end-user pieces, and finally, in my case, our expertise also in the recovery of good quality plastic waste. So, to start with the little sum up of the recycling technologies, we will go later with our wind project, and we choose some of these technologies to apply to the wind turbine blades. I think this is a good sum up, because when we have a waste, the most typical and more higher TRLs nowadays is the mechanical recycling. For example, with the bottles of PET, it's very common to extrude and obtain another pellet. We need to we can make only this with thermoplastics, as say David. And also another possible recycling process is with physical. It's basically the dissolution process. For example, we could, in packaging, dissolve the glue of different layers, and after that we will recover separately the different materials, and we could obtain a waste to go to the mechanical recycling. But, well, as you know, we could use it for a lot of typical polymer and plastics materials, like textiles or packaging, bottles. But when we talk about wind turbine blades, we are talking about thermoset materials that basically we need to go to another kind of recycling process. In this matter is when came the chemical recycling. The first one is the polymerization. One could be with biochemical process, another with the solvolysis process, applying some reagent to attack the polymer chain, or with thermochemical process. Normally it's pyrolysis and could be also gasifications. Normally with this kind of recycling processes, we obtain some monomer or some chemical with high value more than the waste. We could use this monomer to make the same material, but one thing that we need to know is that this monomer that we recover, it's a new species that we could use it for another markets, for another applications, and has their own value. And the last part is the conversion to energy, because with the pyrolysis also we could obtain naphtha, because we could use it in the petrochemical to make gasoline or diesel, but we also could recover some ethylene or propylene to make also some polymers. So this is the sum up of the different technologies, and now we are going to see which ones are we using in the Wind project. So the Wind project is basically our target is the efficient decommission, repurposing, and recycling to increase the circularity of the end-of-life wind energy systems. So this is the consortium. We have a consortium with a lot of different countries, a lot of different companies and entities with different focuses, because it's not only talking about recycling, we are also talking about new technologies to the decommission and new technologies to the dismantling to cover all the entire value chain of the wind turbine blade, starting from the decommission and obtaining the new material with some percentage of this recycling content parting from this waste. So to put into context, obviously I think you know, because we already talked a lot of this, but currently a lot of use of a lot of tons of wind turbine blades are going to be decommissioning in the next years. So we need to start and go further to make these new technologies that could be scalable. We could obtain some profit, and some entities need to have this profit using these technologies. And obviously also with the legality that are going to make this prohibition of these composites to go to landfilling. This in European scale, but on global scale, more than the same. It's estimated that millions of these tons are going to have this final end of life. And the circularity of wind turbine blades is basically close to zero today. It's true that there are some projects and there are some parts of these wind turbine blades that are recycling, but as Gianfranco saw this part, but it's true that normally it's a downcycling more than upcycling. That is what we need to achieve to obtain a new material that could have higher value than the starting point. So the cost-efficient recycling of composite materials remains still a challenge. Is why the Wind project comes, because we want to contribute to the increase of this recyclability of the wind turbines blades, developing critical technologies for this dismantling and repurposing and recycling parts. So I will show the concept and how is the Wind project put. The first part is the dismantling. We have Suez as partner making this part. They are making different technologies to try to obtain as better as possible these different parts of the wind turbine blades. Later, some quality inspections, because once we have this part, we want to see if it needs a recycling process, or maybe we could reuse it in another applications, because we need to have a huge view, not only trying to make the recycling, because maybe we can, for example, make a repurpose to another materials with another applications. In the Wind project, these different materials, we are going to use it, for example, in construction for some acoustic insulation panels, or in automotive to make some isothermal van box body. Also, we are seeing and we are developing, in that case, Techniker, some new technologies to obtain as much as better this kind of materials to repurpose. But sometimes these quality inspections could come that we cannot repurpose and we cannot use it in another applications. That is when the recycling process came. Taking in account that what we have is a thermoset plastic, what we need to make is a solvolysis process or a pyrolysis process. I will explain a little bit more later, but basically we could recover different parts, or the glass fibers or carbon fiber, or some monomers, or some naphtha to go to the petrochemical industry. We will see it later a little bit more deeply. That is the big part that AIMPLAS is contributing and developing with all the expertise that we have in the recycling technologies. So the outputs of this recycling, normally the monomers or the recycled glass fibers or recycled carbon fiber, another partner is going to apply some sizing. The sizing basically is some coating that is put to the fibers to improve the integrity to another material, so improve the quality. And after this sizing of the glass fibers and carbon fibers, we are going, and also with the monomers, we are going to make some synthesis of recycled resin and bitrimer resins that, as say David, also are very increasing the choose to obtain this kind of polymers. So what we will obtain finally is a composite manufacturing with the carbon fiber and the glass fibers coming from the recycling content, and with the monomers also to put some percentage of these recycled monomers another time in new resins. Could be for the same purpose about wind turbine blades, but another time we need to take in account that could be to make another kind of composites, because what we are obtaining is a monomer that has her own value and a new glass and carbon fiber that has her own value. We could make different materials to improve this circularity, not only the same sector, but it's true that in this kind of project, we want to reintroduce in the same sector of wind energy. So this is the sum up of the process to see the goals, while demonstrate these technologies for the commissioning that of the end-of-life wind turbine blades and the sorting of them, repurpose of these end-of-life composites in industrial application, as I said, with automotive or construction, to develop this cost-effective, very crucial, that needs to be cost-effective and scalable, the technologies of the recycling to improve the properties and the performance of these materials, and obviously also from this output produce good quality yarns, fabrics from the recycling fibers, carbon or glass fibers, coated with the sizing that I said before. And obviously all of this needs to have some study to improve this environmental and economic sustainability of all the processes and products. And the final part is to maximize the socio-economic impact of our wind, including stakeholders engagement and social acceptance with some shows like today. What are making AIMPLAS? Well, is the project coordinator and the leader of the chemical and thermal recycling task. And also, we are in the synthesis of the new materials with some recycled content. We make the pretreatment of the end-of-life composites. We make this characterization of obtain the different fiber and recycled carbon, and making this pyrolysis and solvolysis process. Also, we develop this new formulation of new recycling polymers with V-trimer or epoxy resins, and to obtain also some final recycled polyester polymer. So as you see, we are in the recycling part and the synthesis part of this material. And to finalize, I want to show some real results that we obtained after the grinding process. What in one of these composites were with glass fiber, but also with wood, because it's a composite material that could have another material, and one glass fiber with polyester. But with the heterogeneous mixture of wood and epoxy resin, after some air-based density separator or water-based density separator, we could separate the wood and the fibers differently and could go to the process making some good sorting. And well, this is the example with pyrolysis of the wind turbine blades. We obtain, as I said, 3 different parts: the fibers, the pyrolytic liquids, and the gas that normally is reintroduced in the same process. And with the solvolysis, we obtain also the fiber and a reaction crude, which obtains the monomers. With after the purifications, we could make another polymer. Only to show the different fractions, now we are making these characterizations to start with the synthesis all of the with the monomers and with the fiber content. The same with the solvolysis. In these liquid fractions, we make this purification. This is now in a low TRL, but we are going to start increasing the TRL of the solvolysis process. This is all. Sorry for the minute that I passed. And if you want to know more about the wind project, you could scan the QR. Thank you very much, and I hope you enjoyed it.
Many thanks, Nacho. I mean, I think it was a very clear presentation, very interesting as well. I mean, my question would be more on, I would say, the market side of things, or more like, this is one of the big, sort of the big questions that are always around the context of recycling technologies and who is doing sort of what's the most developed one out there. But the question is, looking at pyrolysis and solvolysis that you also showed now, and also very clean fibers, to be honest. What are the end users today? Where do you see the end users also, I mean, from an industrial application point of view as well? If you already have any, you already hinted a bit, but yeah.
Yes, well, basically, first of all, normally the most easy one is that the pyrolysis will go more easy to the higher TRLs and in the industry, because the pyrolysis is already in industrial level. And basically, when we talk about the pyrolysis, the petrochemical industry is the first market that will go. And in that case, the fiber and carbon fiber glass, sorry, glass fiber and carbon fiber will go to the could go to different companies. Normally, to the companies that are processing the last materials, because it's true that maybe we need to make a new company that could make the different changes in these fibers to make it more easy to reintroduce in the final application, to make the sizing as we see and the final material. And regarding the solvolysis, we finally obtain a monomer, and after the purifications, what we obtain is a chemical. So all the industry regarding the chemical could go in that sense.
That's very clear, honestly. And maybe, Justine, you have any questions from the audience?
Yeah, there are many questions in the audience, and I'd like to highlight that you can like each other's questions to rank them up. So I'll take the ones that are already liked and try to group them, because there are many interesting questions. There are questions about the information you need in order to perform your process. How much information do you need? Could it work for different composites? Like sometimes there are composites in the nacelle, not only in the blade. Could this go in, for example? Yeah, and in general, do you need a material passport on the blade or on the composites in order to select the right parameters and so on?
Yeah, well, normally as more information, the better, to could tailor it better the process. But it's true that, for example, in case of pyrolysis, could be more easy one, in sense of it's not, for example, in solvolysis, we need to make some reactions that could attack some selecting bonds, and the final monomer could differ a lot depending of the composite that we use. But in case of pyrolysis, what we obtain is a pyrolytic liquid, and always that you make some analysis of this pyrolytic liquid and have the sufficient requires to go to the petrochemical industry could be accepted. I don't say it, but during the process, we make the pyrolysis also with different catalysts, because finally the catalyst could improve this quality of the pyrolytic oil. But basically, with the pyrolytic oil, it fits the requirements of the industry of the petrochemical, could go without problem. And regarding the fibers, it's not a problem, because the fiber is the result to crack all the polymer chain. So I don't know if I have explained it, but
and then we have questions about, still related to the process, how much volume do you need to make the process run like on a commercial level? And the question is actually, how much blade waste volume have you processed so far? Which scale are you working on in the project?
now we are working in AIMPLAS. We work in the TRLs before the industrial level. That's our purpose. We work with all the companies that has a huge pyrolysis reactor or huge reactors that cannot stop her production or cannot have this time to make all the development of the technologies. So in AIMPLAS, we work in TRLs between starting 2.0 up to 6, 7, depending the technology. And we work also with these companies that could make this TRL up to 8, 9. And in our wind project, regarding pyrolysis, we have one company that is working in higher TRLs. It's true that in solvolysis not. That's what I say, that solvolysis maybe needs more years to go more deeply to the industry. So to sum up, the pyrolysis we have in more higher TRLs and solvolysis in less.
Another question, is repurposing included in Rewind, and what are your research there? There's a comment saying that repurposing is about using the material with their current qualities, so like for bike shed and so on. Is this part of the project, and what is the...
Yes, it's similar like the book market that so Gianfranco, but for another purpose. I mean, the technologies that are developing to repurpose finally is different technologies to cut the wind turbine blade, to could use it directly, maybe some pre-treatments, but try to use it directly to different applications like automotive or whatever.
Okay, so it's more on the cutting. Do we have time for...
I think also being mindful of time, maybe we can move to the next presenter and then we can have more questions at the end.
Yeah.
All right.
Okay.
Many thanks. Many thanks, Nacho.